We're still working on the idea of linear equations in disguise and the method of solving those by finding our cross products. So still working in lesson 4.8 here, module 4, lesson 8. Now this one is going to talk about similar triangles. Okay, so somewhere along the way, we set up proportions based on similar triangles. Even if you don't quite remember it, basically what a similar triangles means that they're growing at the same rate. They're bigger or smaller proportionally. We don't take one side and multiply it by 2 and the other side and multiply it by 8. They wouldn't be similar then. So similar says each side is a ratio of each other. Twice as big, 3 times as big, twice as, small, 3 times as small, or a third of the size. So we can use that to set a proportion. So here's how you do that. Pick one of your unknowns. I am going to pick x minus 2. And again, I'm going to star this one here because you're going to want to see one like this on your homework. This right here, AB, is going to correspond to A prime, B prime. Okay, these two sides are the same. So as I set up my proportion, I kind of say, well, you know what? These two kind of go together. There's different ways we can set up a proportion as long as we keep them lined up horizontally or vertically. So I could put the 9.5 underneath if I wanted to. Okay? So now I'm going to do the same thing right here. X plus 2 corresponds, AC here corresponds to A prime, C prime. We'll get more into that language later. Okay? AC, A prime, C prime. Okay, this is same figure. These are both on the same triangle here. These are both on the same triangle. These two sides correspond to each other, and these two sides correspond to each other. So this proportion set up. You can set it up differently as long as same triangle, corresponding. I mean, you could have x minus 2 over 9.5 and x plus 2 over 12, as long as you kept things lined up horizontally and vertically. Anyway, once you get things set up like this, then this is just a cross products property. It's a linear equation in disguise. So I am going to go sloppy, as always. 12 times the quantity, so in parentheses, x minus 2, and 9.5 times the quantity, x plus 2, and we set them equal to each other. This is what the cross products property says. And now, use the distributive property and solve. So 12 times x is 12x, minus sign, 12 times 2 is 24, equals 9.5 times x, plus sign, 9.5 or 9.5 times 2, which is 19. Okay, we have variables, x's on both sides. So at this point, simplify, but I want the x's all together on one side. You can either subtract 12 x's from each side or subtract 9.5 x's. And that's what I'm going to do. Again, doesn't matter though. And these are x's. I line them up because if I have 12 x's and I take away 9.5, I'm left with, even if you can't do it in your head, it's 2.5 x's. Then I bring down my minus 24. I bring down my equal sign. These cancel. That gives us 0 x's. Anything times 0 is 0. And then I have 19. Now I have a two-step equation. I'm going to solve for my x term, get rid of whatever's being added or subtracted. So I am going to, if we have minus 24, I think it was negative 24, I'm going to combine that with a positive. Whatever I do to one side, I do to the other. Bring down my 2.5x. These cancel. 19 plus 24 works out to be 43. Yep, that was right. And then this is times, so I do the inverse and I divide. 2.5 divided by 2.5 is just x. 43 divided by 2.5, 17.2. All right, so x equals 17.2. Now I want to stop it. I want to go back to my question. And it just asked for the value of x. If it asked what the side lengths were, I would just plug 17.2 in for x right here. But the directions just say to determine the value of x. So make sure you check that on your homework. Okay, once you get it set up though, same way. One more example. Okay, so the following equations of rational expressions, if possible. And again, linear equation in disguise. Let's see if it works. 7 times the quantity, 5 plus 2x. Please be careful to put the stuff in parentheses. 6 times the quantity, 3x minus 1. Use our distributive property. 7 times 5 is 35. Plus sign, 7 times 2x. And guys, the more you write down, the actual easier it is. That's 14x. Trying to keep it in your head can get confusing. 7 times, I'm sorry, no, that's a 6. 6 times 3 is going to be 18x. Minus sign, 6 times 1 is 6. Now, simplified, two-step. I'm sorry. Now we got to gather all our x terms up. Kind of see how you guys would keep adding a step on top, and we keep doing the same thing over and over again. All right, I'm going to get rid of the 14x's. It's smaller. Then I have to deal with positives. So I'm going to subtract 14x's from each side. That leaves me with 35 at 0 equals, if I have 18x's and I take away 14 of them, that's 4x's. Bring my minus 6, two-step equation. Solving for 4x, I have to get rid of this minus 6, so I'm going to add 6. Whatever I do to one side, I do to the other. I add these together, I get 41 equals 4x. That's 0. This is 4 times x, so I divide by 4. Now, 41 divided by x, I think that's probably not too pretty. No, it's not bad. It's 10.25. Okay, I was wrong. So you could leave it like this. You could write it as, well, it goes in there 10 times. That's 40, and there's 1/4 left over. Or in this case, since he didn't give us fractions to start, I could leave it as 10.25 to finish. So the big thing, ladies and gentlemen, is don't be intimidated by problems like this. Don't be intimidated by problems like this, maybe. Set up the proportion. Use your cross products property. And then just solve them using all the tools and skills we've been working on.